So this problem asks you to comment on the stereochemistry of the products formed in these reactions, and this is again something that we discussed in the classroom, where when you can have a newly formed stereogenic center from a non-stereogenic center containing molecule, you can have both of the enantiomers formed in equal amounts. So if you take this styrene here, this is styrene, which it contains a double bond, and the double bond can react with electrophilic reagents like a typical alkene would. So here we have an H plus reacting with the double bond first, and as long as the mechanism is concerned, we know that the alkene bond is polarized towards the proton, and the proton goes to the terminal carbon. So you are going to get a CH3 here, and that carbon will get a positive charge, and as you can see, there is one hydrogen here and there is a hydrogen here. And now this is a planar structure. This is an sp2 hybridized carbon, and it's a planar structure, it's not tetrahedral. And when water reacts as a nucleophile, and if you consider this the whole molecule to be in the plane of the screen, then the hydroxyl group can attack this carbon center from behind the plane of the screen, or it can attack this carbon from the front of the plane of the screen, and based on that you will get both enantiomers. So you can either get that or you can get that. So both of these front and rear end attack are going to have equal probability of happening. Therefore, you will get both the R and S configurations or enantiomers in exact equal amounts. Therefore, the product is going to be a racemic mixture, which is going to be equal amounts of the R and S centered molecule. Whereas the second example is not going to be as straightforward, because here again you have the same alkene bond as you had in styrene, and you're reacting that with the same water and acid, which are the reagents. So if it's an R center, so let's say this is the molecule you're reacting with, which, as I say, it's an R enantiomer. So priority 1, 2 and 3, that's clockwise, fourth priority group here. And if this molecule reacts, then you can get on that carbon both R and S chiralities. So you'll get a product which is going to be, so you can either get an RS molecule or an RR molecule. The RS molecule, as you can see here, as we have discussed in the classroom, is going to be a mesostructure, whereas the RR molecule is going to be an enantiomerically pure compound. Therefore, this reaction is going to result in a product which is going to be an enantiomerically pure structure, and it will not lead to a racemic mixture.